Hello everyone, this is your friend Flopolopagus, and today I'm here with some engineering for you all. I'm currently using Autodesk Fusion 360, and I have a task. When I was playing Airsoft just the other day, I accidentally broke the included mount for my Ekens, E-K-E-N, action camera. Ready? Using it as my face camera that I mount to the front of my weapon platform. However, when I was playing Airsoft, my weapon took a hard hit when I threw it against a wall when trying to get into cover, and I broke the mount. So today I'm going to redesign a mount for my Ekens, and it's going to be 3D printed, hopefully out of ABS if my Prusa i3 Mark IIs wants to cooperate with me and actually print the ABS without any issue. So let's get started with this. So the first thing we're going to need is our base here. I'm going to start, and we're going to get our first rectangle going here. So what I'm going to do is I'm going to measure my Ekens camera. Kind of sounds like I'm saying heckin'. Going to measure this Ekens camera. Heck. Alright. We should be safe at 60.1 millimeters by 42.1 millimeters. Don't know why my second measurement changed, but we can fix that. And find out what I measured. 61.1, I believe. Sorry, that's 61 or 60? I'm getting a different measurement now. I'm not using really great calipers. I'm using some semi-cheap calipers, so that could be the reason why I'm getting some discrepancy in my measurements by about a half a millimeter. So we're going to use 60. I like having extra space. We're going to do 61. 60.1, sorry. 42.1, 60.1, and this is going to be the size of the camera. Now what we want is to offset this for the thickness of the wall. I want 2.5 millimeter walls for a little extra strength. Usually I go with 2 millimeter, which is usually fine, but this is going to be a piece that takes abuse. I actually might even go to 2.8. Let's do that. Alright, now we have our base piece here. So now we can do our first extrusion. I'm going to select both surfaces, and we are going to go backwards. Doesn't really matter. Yeah, it kind of does. What do I do? 2.5 or 2.8? Oh, sorry. 2.8. I can do me. We're going to want to go to our sketch thing and re-highlight that sketch we just did and do another extrusion. Now we got to get the measurement of our camera, their depth. $25 millimeters. That went the wrong way. There, now we have a box. What a beautiful box. But we're not just going to throw this in a box. We're going to make it neat, I guess. So, but it is a start. So specifically, since this camera, normally what you'd want to do is you'd want to go to the back and you would want to open it up so you can see the view screen. However, since this is a camera that's mounted to the gun, that would just make a space for BBs to break the screen. So we don't want to do that here. Instead, turn that sketch off. Instead, what we want to do is leave it and work on the mount for the camera. So we're going to want to look at a side. And remember that the opening is down towards the bottom this time. And we're going to want to make another couple of rectangles. First, you're going to want to start a sketch. Now we can make some rectangles. So this is going to be the part that actually holds it in. I like to make this 1 millimeter past the lip. So we're going to do 3.8. And it doesn't have to be terribly long. I'm going to go with 3. See what that looks like. Doesn't look too bad. And we're going to want to repeat the process on the other side. 3 and 3.8. Now we're going to want to do another extrusion. Except this time, we're going to want to do an offset extrusion. So we're going to do an offset plane. Now we're going to want to figure real quickly. I'm going to inspect this. Remember what that measurement was, 65.7. I'm going to open up my calculator because I know do math good. So we're going to take 65.7 divided by 2. Now we're going to want to make these pieces, I don't know, let me take a look at my ruler, find out what looks good. 15 millimeters sounds neat. So half of 15 is, let me think for a minute, 7.5. So we're going to want to take that measurement and subtract 7.5. 23.35. That's our offset. All right, so let's go back here. Start our offset again. Select both. Profile plane, offset plane. And our offset is going to be 25.35. I'm good at this. 35. Sorry, that's negative 25.35. And then our negative distance is going to be 15. There. And this is going to be the chunk that holds the camera in place. Now let me just make sure that doesn't interfere with the lens. It doesn't look like it will, so I think we're safe. So we're going to do that. All right. We're starting to look like a thing here. So the next step I want to do is when you slide the camera past this, it needs to do two things. This stuff needs to stretch, which it's not going to do in its current state. And these need to, it needs to be able to slide past it. So the first thing we're going to do is make it slidey. So we're going to modify, we're going to go to chamfer. We're going to select both of the surfaces facing out. And then we're going to do it by 2 distances, that's what we want. And this doesn't have to be super precise, this is just kind of an eyeball. So we're going to bring you into 2 millimeters. I'm going to bring that up. That technically only has to be 1 millimeter, but I like to play it safe and do a little extra, so 1.5. And as far as this one goes, we're going to do 2.5. There, and now it's got some slidey room to slide the camera in. Next thing I'm going to do is make sure it bends. So we're going to start a sketch on this plane. We're going to do a rectangle again. Go down to there. Sweet, that's what we want. And we're going to come out, just need to come out 1 millimeter. That's fine. We're going to do the same thing on the other side. No, we're going to do the same thing on the other side. Boom. And that's going to be 1. Alright, and now we're going to hit the extrude button again. Select both. Oh, well, that didn't want to do it right, so we're going to select them like that. That'll get the job done. And we're going to go backwards. And I found that these ones actually have to have quite a bit of girth to them in order to make it slide properly. So we're going to go back as far as 13 millimeters. That should be enough. I'm going to have it cut. So that way these fins here, they can move a little bit freely. As a matter of fact, what I might even do to make them a little bit more pliable is take this. We're going to do another sketch on here. Draw a rectangle. Actually, we don't have to. Control-Z that. We only need a line. Don't need to over constrain here. Then we're going to hit modify. Do that. We're going to minus that by 0.8. That look like it'll be enough? Let's modify that by -1. Yeah. I'm going to do the same thing on the other side. Doop-a-doo. Modify. -1. There. Now we've got our fins on both sides. Now we want to make that look a little bit less like poop. So we're going to modify again. We're going to chamfer. We're going to go equal distance. And we're going to select, go the right way. This line, that line, and we're going to come out to that. There. Now it's blended a little bit better. That doesn't look too bad. Right, so those should be able to do the things that they're supposed to do. Now, the next thing that we need is to work on our mount. So, if you guys don't know, most camera equipment, and actually all camera equipment in my experience, uses a 1/4-20 thread to screw into things. So I have a 1/4-20 hexagonal nut here, and I'm going to give this thing a good old measure, and we're going to find out exactly how big our little reservoir for it has to be. I call it a reservoir. That's definitely not the right term for it, but I don't think anyone here is going to mind that too much. It looks like 20 millimeters will do the trick, so I want a box 20 by 20. So we're going to just designate a bottom side here, and I'm going to make it this side. The next thing I'm going to do is draw a line, and I'm going to go, line I said, from the center point, and it snaps to it, to that center point. Okay, and we're going to take that line, and we're going to turn it into a construction line. I just right-clicked there to do all that good stuff. Now we're going to sketch again, and we're going to do a center rectangle. Find the center of that, just so it looks pretty good. And 20 millimeters isn't going to do it. It's going to come over the side. Unfortunately, we didn't give ourselves enough slack. So, new plan. We are going to take this center rectangle, put it anywhere on here, 20, tab 20. So that'll work right there. I'm just going to hit enter there. So that'll work right there, but we want to constrain it so that way it's not just floating in the breeze. So we're going to go take our sketch dimension, find the center point of that, and constrain it to the outside. That's really close to 12 millimeters, so I'm just going to use 12 millimeters. So, and there we have it. Now, you'll notice that this kind of goes into our block for this. I'm not going to worry about that. I'm going to let that be an open space for this thing to bend. So we're just going to let that be. Now we need to figure out how thick we got to make it. $10 millimeters should do the trick. So remember, we've already got a thickness of 2.8. So to make the rest of that, we only need 7.2. So we're going to create. We're going to select both surfaces. 7.2. That looks like a large, ridiculous chunk that just comes out of nowhere, doesn't it? Doesn't look too well designed. It just looks very chunky. So, we're going to make sure this is all the same body too. Yes, it is. Good. Very good. So what we're going to do now is we're actually create a section plane. And the reason this is I need to be able to see this more clearly in order to design it well, so I believe that's under Insert. I was wrong. Inspect, Section Analysis, select this face, and do that. Now we have a section plane. Sweet. Now we can work on you. What we're going to want to do, because we can't see this plane through it, I'm just going to want to measure real quick the distance to here. So I'm going to inspect that, and that is 2 millimeters. So 12, that's right, it's 12 to the center. We should have known that already. And that rectangle is centered. So we're going to close that. We're going to start a sketch here. And what we're going to do, oops, didn't want to do that, is we're going to get our polygon circumscribed and set it to the center. Can I? No. That don't matter. Well, it kind of does. What you want to do is you want to have the point coming up there. So I honestly can't remember what the angle on a hexagon is. It should be 360 divided by think 6, obviously. So they should be 60 degrees. So let's see if we're right. First, I'm going to sketch out from the end, the center, a 12 millimeter line. I'm going to turn that to a construction line. I'm going to do another line at 60 degrees. And this length needs to be, let me just get my handy dandy calipers here and measure this out. .5 millimeters. That's not correct. That is the diameter. We need to half that, so 6.25. Now we're going to go back to our circumscribed polygon. Do that. And look at that. It lined up perfectly. However, that is also wrong. We're going to undo this real quick. We're going to edit this. That needs to be the distance to the flat. So the diameter of it, or the full distance to it, is 11.2. Should give us enough clearance. So half of that is 5.6. There. Back to our circumscribed polygon for the third time. Do that. There. Now if we take our inspect, go from one to another, 11.2 right here. So that should be our hexagon. Now the reason I did that is because whenever you design something, you always got to think about how something's going to be printed. So I'll explain that in just a second. We need to get our depth here with a safe depth so that way our camera can fit in there nice, which is going to be 6 millimeters. So we're going to create -6. That's going to cut into that section. Very nice. So I'm going to explain this to you real quick. When you print something in 3D, let me just turn off this analysis real quick. There. When you print something in 3D, you've always got to figure out what the best way the printer is going to have to go at it. What that basically means is when you have things like bridges, which is exactly what this is going to be, you need to figure out the best way to do it. So when a 3D printer prints, it's basically a hot glue gun that shoots downward. So if there's nothing below it, it means the 3D printing filament can just fall straight down to the plate, and you're going to ruin stuff like this. So let's pretend this is being 3D printed, right? If we 3D print this direction, so this down here is the floor, this up here is a long bridge, which means it's either going to sag when it prints it or fail completely. So we don't want to print it that direction. Oh, wow, geez, what happened there? Sometimes the orbiting tools on here just don't want to work properly. Yeah. So, that's no good. So, the best way to print this one is going to be this direction. Why is that? Because there's no real bridges except for this, and it's a small bridge at that, and it leaves things like this nice and open, so that way when it prints upwards, this is going to be a nice gap. It's not going to be distorted at all. The only things we have to worry about is this right here. So that can droop because that's printed over nothing, so that'll use supports. And inside, turn our analysis back on, and inside here, where that's going to be cut out. So what's working to our favor, however, is this is more of an arch. So when it prints, it's going to print a little bit on the last piece of filament each round. And so that should help this keep its form a lot better than, say, something that's printed over nothing like this. So that should be okay. So the next thing we're going to do, and we actually kind of forgot to do it. So this is great to demonstrate how you can go back in Autodesk Fusion and fix things. So if I go down to my timeline here, I'm going to right-click this, and I'm going to edit that sketch. And look at that. We went back in time. It's like it never even happened. So what we forgot to do is to make our bolt hole. So our bolt hole, these are 1/4 I don't have a bolt with me to measure, but 1/4 means it is a 1/4 inch by, I honestly can't remember what the 20 stands for on the 20 thread. I think it's 20 teeth per inch. I think that is what 20 means in 1/4. So here we're going to want to look and do our, yuck, 1/4 is 0.25. So we're going to want to transfer that into millimeters because that's what we're using here. So there's 25.4 millimeters in every inch. So we're going to multiply that by 25.4. So 6.35 millimeters is the diameter. So we're going to want to do half of that, which is going to be 3. We're going to calculator. Let's just do that. 3.175. We're going to want to widen that a little bit, so I'm going to do 3.25, so that way the bolt has enough clearance. So we're going to go in here. We're going to, not a rectangle. We don't want a rectangle. We want a circle for the center. And this is the diameter. So we actually could have used the diameter. What did I say that was? Oh, I can't remember. I'm going to our history. 3.175, so it's 6.35. So let's do 6.45. 6.45. Sweet. We're going to stop that sketch, and you'll notice it disappeared again, but that's okay. We don't have to worry about that. What instead we will do is we will go on to our diagram over here, whatever this is called, and we'll make it visible again, and boom, it's right there. So we take that, create, zoop, cut all the way through, and okay. Now, there we go. It's cut through. So this is still pretty blocky, and I don't like how blocky it is. So to remedy this, I might loft it. However, thinking it's not going to be the easiest thing to do now that we've already gotten this far. So I might take the easy way out, and I'm just going to fillet those corners. Make it a little less blocky. Did I say those other things are the only things I had to worry about? This is sitting over nothing as well. So that's also going to be an issue. And hopefully the bridge. So this was printed over nothing. Remember how we were discussing that? So This block's going to make my life difficult. It's going to make my life really difficult. So, I noticed I made a slight design error. We're going to continue as if I didn't notice it. So, we're just going to swoop these in a little bit till it looks pretty good. That looks pretty good. Turn off our section analysis. There, now I've got this. So, when this prints, this is over nothing. So, it's going to generate supports to hold this up. So there's a lot of material here before it gets to what's important, so I'm not too worried about it. So we're going to let that go. If I look at this, so you can still see that sketch because I never turned it off. So you're going to have this much material between this point and the bottom here of meat that it's going to have to grab. So again, I'm not too worried about it. It's fairly small. And so some other neat things you can consider when doing this, I'm not sure if I'm going to be able to show you. See this gap right here? That's our gap right here. Right there. So you can see into that, but I don't think that'll be a big deal. I think that'll be okay. Again, it's got a lot of other meat to hold it in place. So if you can kind of probably see exactly what I'm going for here in this camera. So the last thing I'm going to do is I'm going to clean up these edges as well. So we're going to do modify again and chamfer. I'm going to select all these edges out here. We're going to make them a little less hard. Did I say chamfer? Cancel that. Modify, fillet. I want them smooth as butter. There. Just like that. That should give us plenty of meat around the corners and make it look a little less boxy. Right. So, there we go. And I could leave this as a block like this, which is fine. I'm not worried about it. So yeah, there we go. I think we're pretty much done here. Do our last checks. So this should be able to hold the camera in place. So our last step here in our first printing test, we're going to go to body, right click, save as STL. Now all this information I usually just leave as default. I don't mess with it at all. Refinement as medium is fine. Send OK. It's going to ask us to save it. This is our face cam mount. Save that. One last check to make sure I did everything right. Make that go in here. Let's turn sketches on, but make that not visible. There we go. Just to make sure I didn't screw the pooch here, I'm just going to check it real quick. I think everything is just the way we'd like it. Camera's going to fit in here after you put the nut in here. The nut is going to attach to the bolt right here. This is going to sit on the rail that I have sticking out of my gun. I'll have to show you guys some pictures after it's done. And yeah, that should do it. So let's send this to the printer. I will see you in just a second. Just kidding, I'm going to see you again now. We forgot to slice this. When you 3D print, you have to slice your stuff. I'll show you what that means in a second. Go to here, open up our slicer program, which is our Prusa SLIC3R, I think it is. Yeah, SLIC3R, Prusa edition. Add, we're going to find in the parts folder the part we just made, which was our face cam mount. Open that up. It's going to put it in here, and I notice it's going to be in here wrong. This is the base of our printer. If it printed it like this, it would be all sorts of screwed up. So we're going to right-click it, and we're going to rotate. And if I remember correctly, this was made upside down, so we need to rotate this to 70. Yes, perfect. Now, it's currently on the correct direction. Now, no matter how I move this, it's going to be still on the table. But this program is great at organizing itself, so we just hit arrange. Now it's in the center. Now notice how this is bridging. So what we're going to do is we're going to go to print settings, we're going to go to support material, and we're going to generate support material. It's going to ask us if we want to set it for a wipe tower. We don't need a wipe tower. Now it's going to ask us if we want to enable detect bridging, which is yes. That's all set. I don't touch any of this stuff. Our infill, because it's going to be quite the infill, it needs to be strong. We're going to set my infill to 40%. That's pretty decent. Usually you only need an infill between 10 and 20%, but this is going to take BBs, so we'll set it to that. Right now we have it set to PLA. We're going to take this and we're going to set to Prusa ABS. Just the regular, because I haven't had any good luck with the hatch box I set up. So Prusa ABS, and we're going to hit slice now. Now we're going to go to our preview, and I'll show you what it means by bridging. This is bridge material. See how it prints this material down here. I'm trying to get a good view for you, but it's tough. Yeah, right here. So this material is stuff that I'm going to remove after it prints, and it's going to have bridging material up here as well in our bolt hole. It's going to have bridging material all the way up into here and all the way up into here, which should all pull out after it is finished. So we have our piece, we have it sliced. Now we can export the G-code. Now, whenever you export G-code, you always want to make sure, just for organizational sake, to label what the material is. This is ABS. So face cam mount ABS. Notice how I have everything else labeled the same way. PLA, 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 PLA. I print a lot of PLA. I like PLA. Save that. There we go. Now I will see you in a few seconds. So we've printed the part. Now you probably noticed that it doesn't look exactly like how it did when we left off in the engineering portion. That's because I added these little thumb areas in the design because I forgot to do them earlier, or else how else would you get the camera out of here when you're done with it? So, but we have it and printed it. Unfortunately, I couldn't do the ABS. If you looked at the time lapse, you'll notice that there is an issue with the ABS. It lifted, so we can't use it, unfortunately. So this is PLA. Not nearly as strong, but it should suffice since I made it extra thick. Now we're going to try to see if this bad boy fits. So, starts nice, and there we go. Now, it stays in there okay, but it does kind of pull out pretty easy. So, that might be a point of issue. Now, if you notice, I've already got the nut in there. I kind of got ahead of myself. Here's the mount that goes onto my weapon platform, and it's got the rail adapter here. But basically what happens is this guy goes here, this guy goes there, it's my lock washer, and this guy goes here. And it should thread up in there. Now, we're not grabbing that much thread. That's an issue. I'm going to actually take the lock washer out and see what difference it makes. Now we're grabbing a bit more thread that time. I like that better. We're not going to have the comfort of having the lock washer in there, but there's not that much vibrations. It should be okay. So that's pretty solid. Throw you in there. There. Just hold on to it like that. Alright, doesn't pop out. So that's a good sign. Alright. You know, this is from the other side. If someone shoots BBs at it, it won't hit it. So there you have it. That is the face cam mount for my weapon platform. If you liked this video, please remember to leave me a like. Please comment on how I did so I can improve on my videos in the future. And if this is the kind of stuff that you like, this thing will be used in more of my milsim videos and airsoft, more building things to come, more video games to come. please consider subscribing, and I hope to see you all again real soon. Bye now.